Mount St. Helens is exploding. A massive earthquake is ripping through the area, and a side of the volcano is giving way, crashing down in a deafening landslide. A towering wall of rock, ash, and debris is roaring down the valley, flattening everything in its path. Then comes the blast, a sideways explosion of superheated gas and volcanic debris. Trees are snapping like matchsticks. Homes are vanishing under an ash cloud so thick it blots out the sun. Ashfall rains down on towns hundreds of miles away. People are scrambling for masks and fleeing roads blocked by mud flows called lahars, toxic rivers of volcanic mud. The air fills with dust. Emergency sirens scream. Airports shut down. Hospitals fill with people struggling to breathe. The sky glows eerie orange as lightning storms ignite within the ash cloud overhead. This nightmarish scenario might play out very soon. Mount St. Helens, the famous volcano that blew its top in 1980, is acting a bit restless lately. According to the U.S. Geological Survey, about 350 earthquakes occurred from February to June 2024, and 12 more from September 2024 to January 2025. It was like a bunch of tiny tremors throwing a party underground. Most were so tiny you wouldn't even feel them. But on May 31st, 2024, there was one that hit magnitude 2.0. It's just strong enough that if you were nearby, you might have felt a little rumble. Don't freak out yet though. Over 95% of those quakes were super small with a magnitude less than 1.0. Scientists say this is the biggest burst of shaking since the volcano last erupted in 2008. But the volcano has already done this before. In the late 80s and 90s, it didn't blow up, so more earthquakes didn't mean an eruption is guaranteed. What's really going on might be something called a recharge, which is like the volcano's version of refueling. Magma, the hot melted rock, slowly climbs up from deep underground and fills a big underground magma chamber about 2.5 to 6 miles down. When magma fills this tank, it can cause a lot of stress underground, which makes the ground shake. Right now, there's no other sign that the volcano is about to blow. No weird ground bulges, no extra gas leaks, no heat spikes. The USGS says this level of shaking can go on for years without anything major happening. The alert level is still at normal. But it was very different back on May 18, 1980. Mount St. Helens unleashed one of the most explosive volcanic eruptions in history. And it all started with a huge earthquake, bigger than magnitude 5. But this wasn't just any earthquake. It triggered a massive landslide that ripped off the top of the volcano and tore away the rock and ice that had been holding everything down like a giant lid. Suddenly, the pressure that had been trapping superheated water underground vanished. That water instantly turned to steam, and boom! It burst sideways in a powerful hydrothermal blast. And that was only the beginning. With the top gone, the magma beneath the surface suddenly felt free. It started rising faster, forming bubbles and erupting with terrifying force. For 9 straight hours, Mount St. Helens was sending ash and gas miles into the sky. This giant blast didn't come out of nowhere. The warning signs started months before. On March 16, 1980, tiny earthquakes shook the volcano for the first time in years. By March 27, after hundreds of quakes, Mount St. Helens had its first little steam eruption in over a century. It threw ash and rock into the air and blasted a crater in the icy summit. The volcano kept getting angrier. That crater grew fast and cracks spread across the summit. At the same time, eruptions went from one every hour in March to one every day by April. Then things quieted down for a while. Few people realized that the danger was just beneath the surface. By May, over 10,000 earthquakes had rattled the mountain. The north side of the volcano swelled outward, growing about 450 feet. It was a bulge so huge that it looked like the mountain was about to explode. Scientists knew that magma was pushing up inside, creating a hidden cryptodome, a giant underground pocket of molten rock. And then it blew, shattering the mountain and changing the landscape. On May 18, 1980, exactly at 8:32 a.m., a magnitude 5.1 earthquake hit Mount St. Helens. Without any obvious warning signs, the entire north side of the volcano, the part that had been bulging out for weeks, suddenly broke loose and slid away in a massive landslide. This wasn't just any landslide, it was the largest debris avalanche ever recorded on Earth. Imagine a giant mass of rock, dirt, and trees rushing downhill. It was like dumping 1 million Olympic swimming pools full of stuff into the valley. When the cryptodome got ripped away, the pressure inside the volcano dropped incredibly fast, and this sudden pressure release triggered a huge sideways explosion that tore through the landslide debris. This lateral blast was insanely fast, over 300 miles per hour, and it ripped through everything in its path. Trees were uprooted, forests flattened, and a giant cloud of ash and hot rock shot straight up into the sky. In just 15 minutes, that eruption cloud soared more than 80,000 feet high, way higher than an altitude of 35,000 feet, at which commercial airplanes fly. The blast destroyed an area nearly 19 miles wide from west to east and stretched over 12 miles to the north. In the zone closest to the volcano, almost no trees were left standing. At the blast's far edge, the remaining trees were scorched and burned. A huge area, about 230 square miles, was covered by a thick blanket of hot debris. That sudden release of pressure also affected the volcano's plumbing system, all the way to the underground magma chamber. With less pressure holding it back, the superhot magma suddenly expanded and rushed upward toward the surface. Starting just after noon, fast-moving pyroclastic flows, superhot clouds of gas, ash, and debris, raced out of the crater at speeds between 50 and 80 miles per hour. Those flows formed what we now know as the pumice plain. Scientists say the eruption hit its most powerful stage between 3 and 5 p.m. When the violent phase finally ended, the summit revealed a brand new giant crater shaped like an amphitheater. All day long, the winds carried over 540 million tons of volcanic ash east across the United States. The ash was so thick, it caused total darkness in Spokane, Washington, about 250 miles away. Ash also fell as far as central Montana and could even be spotted hundreds of miles farther east, all the way to the Great Plains, which is over 900 miles from the volcano. The massive ash cloud spread across the entire US in just 3 days and then circled the entire planet in just 15 days. But there was one more problem. The hot gas and rocks were so wild and fast that they melted and ripped up a lot of the snow and ice sitting on top of Mount St. Helens. That sudden rush of melted ice and water mixed with loose dirt and rock, creating fast-moving, dangerous mud flows called lahars. Those lahars tore down the mountain into the river valleys, and the biggest, nastiest lahar hit the North Fork Tidal River. As this muddy, powerful flood barreled downstream, it picked up more dirt and debris, growing bigger and stronger. It smashed through bridges, crushed homes, and finally slammed into the Cowlitz River, reaching its peak size around midnight, about 50 miles away from the volcano. The whole natural disaster took the lives of more than 50 people. After the eruption, the mountain looked like a wasteland, and scientists wanted to see how life could start fresh in such a harsh place. So, their unusual plan was to release a few gophers to dig around the barren soil. Those busy burrowers churned up ash and volcanic debris. digging deep enough to bring buried bacteria and fungi back to the surface. Tiny microbes, especially mycorrhizal fungi, are crucial because they help plants get water and nutrients. It's like hooking roots up to a nutrient highway. Within 6 years, places where gophers worked got covered with over 40,000 plants. At the same time, nearby untouched areas stayed mostly lifeless. The fungi helped plants grow in the soil that was otherwise nutrient-poor and lifeless. Even old-growth forests buried under ash bounced back quickly, thanks to their own fungal networks. But where forests had been clear-cut before the eruption, no such comeback happened. No trees, no fungi, just burned soil even decades later. Yellowstone is the internet's favorite doomsday volcano. Maybe you heard the prediction. One super eruption, then a continent dusted in ash and temperatures going down. A perfect disaster movie scenario. Yet, geologists worry about a different kind of volcano. One that won't explode only once. It could rip the ground open, flood the entire continent with lava, and make the air unbreathable. And we know this because it happened before. Right now, researchers think there might be around 20 supervolcanoes scattered across the planet. Short story, we fear those. Long story, a major supervolcanic eruption could collapse modern society as we know it. A normal volcano can cause a local disaster. It can wipe out a city and turn a region into a no-travel zone. When Mount St. Helens exploded in 1980, it was huge. The eruption blew the top off a mountain and flattened forests like knocking down dominoes. It showed the world just how scary volcanoes can be. But in geological terms, it's nowhere near what a supervolcano could do. Mount St. Helens threw out roughly a third of a cubic mile of ash, enough to make a football field pile about 150 miles high. For comparison, a supervolcano could bury the entire state of Texas 5 feet deep, and Texas stretches about 800 miles. Volcanoes like St. Helens are mountains that build up over time, layer after layer, like nature stacking spilled wax. They erupt, they cool, they erupt again, and you end up with a cone that looks cool in photos. A supervolcano is like a hidden pit. It resembles a giant underground tank of molten rock covered in a thick slab of crust. Imagine the magma chamber like a huge underground room, and the ground above it is the ceiling. During a super eruption, cracks rip open across that ground and magma forces its way up through them, like steam blasting out of a pressure cooker. Ash and gas roar high into the sky. It can start in multiple spots across a wide area, not one neat hole. The magma chamber underneath can empty so violently that the roof above it collapses, the land drops, and what's left is a massive bowl-shaped scar called a caldera. And Yellowstone is the prime example. About 631,000 years ago, Yellowstone had a massive eruption and it left behind a giant caldera about 30 by 45 miles across. Now it's a national park, but it's also basically a footprint, like a warning. If Yellowstone erupted again, the first super hot clouds of ash and gas could blast outward and burn everything nearby. Then the ash would spread. And ash is not like the fireplace dust. It hurts to breathe, it wrecks engines, and it can shut down flights and machines. Regular volcanoes mostly hit the area around them with lava. A super eruption turns the air itself into a real danger. Ash spreads far and jams the things we depend on. High up, sulfur can turn into a thin haze that will block some sunlight. That can cool things for a while and mess with growing seasons, even far from the eruption. And winds can spread that effect well beyond the US. However, geologists worry about something even worse. A kind of eruption that can keep going in waves and cover huge regions in lava. It's called a large igneous province. It's not one volcano, it's a whole stretch of crust that starts leaking lava through long cracks over and over for a long time. Instead of one giant explosion, it's more like Earth turning on a lava faucet that just keeps going. Imagine a crack in the ground hundreds of miles long. Out of that crack comes a sea of lava, but this isn't the sticky, slow stuff you see in Hawaii. This is hot, runny, fast-moving lava, and it doesn't stop. It spreads, floods low spots, stacks into layers, and then does it again. And that's what makes LIPs scarier than a supervolcano. They drag on. They can erupt in repeated pulses over hundreds of thousands to a few million years. We have scars to prove it right here in the US. About 17 million years ago, the Pacific Northwest ripped open and created the Columbia River basalt. Lava did not just coat the land, it drowned it. The total amount that erupted was around 42,000 cubic miles. That's enough to cover the whole US in lava about 58 feet deep. But how can Earth produce enough lava to bury a mountain range? It's because the planet is still churning inside. Imagine Earth like a pot of thick tomato soup sitting on a stove. Earth's core is the stove, and it's extremely hot. The soup is the mantle, a thick layer of rock that moves slowly. Now and then, a massive blob of superheated rock rises from deep in the mantle, possibly from the boundary above the core. Scientists call this a mantle plume. When it reaches the cooler crust, it spreads out, pushes upward, and when it breaks through, it does not build one neat mountain. It can open long cracks and feed eruptions in repeated bursts for a very long time. However, while lava burns everything in its way, it's not what wrecks the planet. The gas does. These eruptions release huge amounts of carbon dioxide and sulfur, and we can assume the consequences of that because it happened before, and not just once. About 252 million years ago, a massive LIP eruption began in what is now Siberia. It lines up with the worst extinction event in Earth's history, the Great Dying. Around 90% of species disappeared. Huge amounts of gas flooded the air and trapped heat. The ocean soaked up some of that gas and turned more acidic. Acid rain fell again and again. Life on Earth crashed. Scientists believe that in the last 500 million years, there have been 16 major extinctions like this, and that 15 of them line up closely with LIP timing. These geological formations changed Earth so many times, and scientists now wonder, what if Yellowstone and that massive lava flood in Oregon are actually a part of the same system? Look at Idaho from space, and you see a long, flat track across the state called the Snake River Plain. It points from the old lava flood region toward Yellowstone, like a trail. That path exists because Earth's surface moves. The outer layer is split into giant plates that slowly slide. Under Idaho and Yellowstone, a deep, hot zone keeps feeding eruptions. As the plate moves, the eruption zone shifts with it, leaving a long trail behind. That's why the rocks get older the farther you go from Yellowstone. It's the same heat source, just a moving target. And if you roll the plate's motion back far enough, that trail points closer to where the Columbia River basalts formed. That's why some geologists think the Northwest lava flood and Yellowstone could be connected parts of one long-lived system. Finally, if it's all part of one big apocalyptic system, is it time to pack the bags and flee to Mars? Will it happen again soon? Even if they share the same story, that does not mean the worst part is coming back soon. The lava flood chapter played out millions of years ago. Today, Yellowstone is simply where that deep heat shows up at the moment. And sure, it can erupt again, but the most likely eruption isn't some giant doomsday blast. It's a steam explosion, when super hot water flashes into steam and blows rock apart. Lava flows and smaller eruptions can happen too. The caldera-making nightmare is a rare one. If Yellowstone ever started building towards something big, it wouldn't be sneaky. You would see it coming. A lot more earthquakes than normal and the ground lifting faster than usual. The clearest right before signs would likely show up in the days or weeks before it. We cannot stop a planet-scale eruption. We can only watch for the warning signs and plan. But hopefully, if the planet decides to get rid of us, by the time it starts sending warnings, we'll already finish turning Mars into our new home.
These ominous rumbling sounds, the ground shaking under your feet. Wait a minute, that's my tummy. Or it might be Washington State's Mount Adams waking up. It's the largest volcano in the state by both area and volume, and it's recently started to show signs of life after staying silent for thousands of years. Scientists have noticed an alarming uptick in seismic activity around the mountain. And since the last eruption here happened between 3,800 and 7,600 years ago, humanity was still in the Stone Age at that time. This sudden chattiness has scientists, let's say, curious. The U.S. Geological Survey has hurriedly installed temporary seismic stations around Mount Adams to keep an eye on the situation. At the same time, they reassure the public there's no need to panic. Mount Adams doesn't reach the height of the better-known Mount Rainier, and still it covers a massive area, making it Washington's largest active volcano. Interestingly, records show that before September of this year, Mount Adams had experienced an average of just one small earthquake every 2 to 3 years since 1982. And then, the Cascades Volcano Observatory and the Pacific Northwest Seismic Network detected a staggering 6 earthquakes in just 1 month, September. These quakes were all rather tiny, with magnitudes ranging between 0.9 and 2 on the Richter scale. It means they were so weak you wouldn't feel them at the surface. Plus, satellite imagery confirmed there was no ground deformation in the area. Now, at the moment, the USGS keeps Mount Adams alert level at green or normal, so we shouldn't worry about the ground opening and swallowing towns and cities. But the most recent seismic blips have encouraged the agency to install additional equipment for more precise monitoring. Such an expanded network will help scientists notice even the smallest earthquakes, which will help them understand what's happening under Mount Adams. This extra equipment might also shed light on whether this recent activity is a signal of future eruptions or just a random anomaly. If Mount Adams eventually erupted, it would likely produce slow-moving lava flows rather than explosive eruptions like Mount St. Helens. After all, past eruptions have only led to lava flows that travel just a few miles from the volcano, so that's not what we'd need to worry about. A much more dangerous thing would be lahars. These are mud flows that can happen when volcanic ash, rock, and melted ice mix during eruptions. Lahars have occurred near Mount Adams without even eruptions. Rock, weakened by hydrothermal processes at the volcano's summit, suddenly broke loose, creating fast-moving, destructive mud flows. Exactly for this reason, the USGS categorizes Mount Adams as a high-threat volcano. While it doesn't erupt frequently, it still poses serious risks to nearby settlements. Another volcano we should carefully watch is Katla in Iceland. It's one of the country's most powerful and dangerous volcanoes. It last erupted over a century ago in 1918, but if it erupts again, it could be 10 times as powerful as another Icelandic volcano whose name I can't pronounce. See? That one erupted in 2010, completely disrupting air travel all over Europe. An eruption of Katla could release large amounts of sulfur dioxide, which could form sulfate aerosols in the atmosphere. Such aerosols reflect sunlight, which could even cause temporary global cooling. This phenomenon often followed catastrophic volcanic eruptions in the past. Although eruptions are common in Iceland, Katla's ash cloud would likely shoot higher into the sky and cover larger areas of Europe than that other one did. It would ground flights and negatively affect economies. If Katla erupted, it would also harm agriculture, water supplies, and air quality. In 2014, scientists noted that a large eruption could even cause a tsunami that might travel along Iceland's south coast and out to sea. But the potential impact of such a tsunami is still unclear. Katla tends to erupt on a regular schedule every 40 to 80 years, which means that another eruption is statistically very likely soon. That's why Katla remains under close scientific observation. The Canary Islands' Cumbre Vieja erupted recently in 2021, reminding people of its destructive potential. The lava flow from this eruption was devastating. It covered whole neighborhoods and flowed into the ocean, destroying more than 3,000 homes. Thousands of people had to be evacuated. But the craziest thing? Even though the damage was significant, scientists believe it could have been far worse. A massive eruption of Cumbre Vieja could have caused the volcano's entire western flank to collapse into the Atlantic Ocean, triggering a mega tsunami. This hypothetical tsunami could have potentially created waves hundreds or even thousands of feet high. They could have flooded coastlines around the Atlantic basin, including parts of the US and Europe. Luckily, recent studies claim that a collapse of that scale is unlikely. But even though the chance of a mega tsunami is low, scientists still think it's wise to prepare for possible eruptions because there's a chance of extensive damage. The lava flows that occur at this volcano tend to be extensive and dangerous to both human life and the infrastructure on the island. If you decide to travel to Ecuador, you should be wary of Cotopaxi, one of the most active volcanoes in this country. It's been rumbling with minor eruptions since 2022. While these eruptions have been relatively small, Cotopaxi has a great potential for a major eruption, and it has scientists on high alert. If Cotopaxi erupted on a large scale, it could produce a massive ash cloud over 12 miles high, threatening the lives of around 200,000 people in the neighboring area. A serious danger is Cotopaxi's snow-capped summit. It would melt super rapidly in a major eruption. It could lead to destructive floods and landslides that would flow down the mountain and potentially reach populated areas. This combination of volcanic activity and glacial floods makes Cotopaxi a high-risk volcano. A powerful eruption could occur soon, or it could be years or even decades away. But monitoring efforts are in place to catch any warning signs. The next volcano we should watch out for is already infamous, Mount Vesuvius. Its catastrophic eruption in 79 CE destroyed the Roman cities of Pompeii and Herculaneum. Its last eruption occurred in 1944, but Vesuvius remains highly active and poses a great risk to nearby Naples, one of Italy's largest cities. A large eruption would threaten over 3 million people. Many of them live in the vicinity or even directly on the slopes of the volcano. If Vesuvius erupted, it would be an explosive event, with ash, rocks, and volcanic gas ejected at extremely high speeds. And even though such a destructive event isn't expected for a few hundred years, Vesuvius remains one of the world's most closely watched volcanoes. After all, it has a real potential to cause catastrophic damage in a densely populated area. Then we have Popocatepetl, often called El Popo. It's one of North America's tallest active volcanoes, which lies about 40 miles from Mexico City. Exactly this proximity to a metropolitan area with a population of 22 million people makes Popocatepetl especially hazardous. A large eruption could send a massive ash cloud over Mexico City, causing widespread disruptions. Ash could clog the city's drainage systems, contaminate water supplies, and even cause power outages by short-circuiting electrical systems. Plus, lahars could rush down the volcano, reaching nearby towns. Popocatepetl has been showing near-constant seismic activity since the early 2000s, and smaller eruptions are pretty common here. In early 2024, there were 13 recorded minor eruptions, which alarmed nearby towns. At the same time, volcanologists consider such eruptions normal for Popocatepetl. While talking about super dangerous volcanoes, we can't skip Yellowstone National Park. It houses one of the world's largest supervolcanoes. Its last massive eruption occurred about 640,000 years ago. But if this monster were to erupt today, the impact would be much more devastating for the entire planet. States closest to Yellowstone, including Montana, Idaho, and Wyoming, would be most affected, likely experiencing disastrous pyroclastic flows. These flows, which are made of a dangerous mix of lava, ash, and gases, can obliterate everything in their path. Large parts of the country would also be blanketed in volcanic ash, over 3 feet in some areas. On a global scale, an eruption at Yellowstone would send tons of ash and gases into the stratosphere, potentially blocking sunlight and causing global temperatures to drop for a few years. This would disrupt agriculture, collapse transportation systems, and create food shortages on a massive scale. Still, even though there's a popular myth that Yellowstone is overdue for an eruption, geologists clarify that this isn't true. Volcanoes don't follow precise timetables, and the activity at Yellowstone doesn't indicate an imminent eruption. So yeah, that's good news.
Stop for a second and look at the ground beneath your feet. Is it a quiet suburban street, a flat basketball court, or maybe a peaceful stretch of farmland? You probably feel safe because there isn't a giant smoking mountain on the horizon, but that safety is an illusion. Yeah, sure. Yellowstone, Vesuvius, or Mount Fuji, those are the celebrities of the geological world. Giants that dominate the skyline and sometimes blow their tops. But what about a hidden threat? One that doesn't look like a volcano at all. It's invisible, it's silent, and thousands of these traps are scattered across the planet, lurking right under the foundations of our biggest cities. Scientists call them monogenetic volcanic fields. To the untrained eye, they don't look like volcanoes at all. They disguise themselves as innocent hills, flat plains, or just lovely lakes. For decades, they were mainly ignored because of their small size. But new data suggests these hidden systems are far more dangerous than previously thought. And unlike the big giants that give weeks of warning rumbles, these invisible volcanoes specialize in surprise attacks. Hold tight. To understand the danger, we have to look at the plumbing. A standard volcano acts like a simple chimney. There is a central magma chamber and a main pipe leading to the surface. Eruption after eruption, lava flows out the same vent, building a massive cone over thousands of years. Monogenetic fields break all these rules. They don't build mountains, they don't reuse the same pipe. Instead of a chimney, imagine a cracked windshield. Magma deep underground scans for any weakness in the crust over a massive area. It pushes up, cracks the surface, erupts once, usually violently, and then calms down forever. The next time magma rises, it won't use that old vent. It will find a new crack 5 miles away, or 10. This means you can't just monitor one specific mountain. The entire region is a danger zone. And because each volcano is a one-and-done event, the landscape is deceptive. You could drive past a site of a violent ancient explosion every day on your way to work and simply see a grassy knoll. The scary part is the speed. In these fields, magma can rocket from 30 miles down to the surface in less than 24 hours. It moves at a speed of up to 4 miles per hour. That sounds slow for a car, but for melting rocks, that is the speed of an elevator. This isn't just a theoretical problem for empty deserts. Take Auckland, New Zealand. It's a stunning modern city with beautiful harbors and over 1 million residents. But Auckland is built directly on top of a geological minefield. Sounds a bit crazy, right? Beneath rugby stadiums, parks, and busy intersections lies the Auckland Volcanic Field. Those scenic green hills scattered across the city aren't just landscaping. They're the remains of over 53 separate volcanic eruptions. Rangitoto Island, which sits just offshore, emerged from the ocean only 600 years ago. In geological time, that was 5 minutes ago. For years, this field was considered sleepy, but recently, scientists have started noticing subtle changes. The terrifying reality of a field like this isn't that a volcano we already know will erupt again. It's that a new one can pop up and go from zero to a disaster in the blink of an eye. A bubble of magma could rise silently beneath a factory, a highway interchange, or a residential neighborhood. There is no designated safe zone because the threat is spread across the entire city map. History gives us a brutal example of how fast this happens. In 1943, a farmer named Dionisio Pulido was plowing his cornfield in Mexico, on the outskirts of Mexico City. It was a normal Tuesday. Suddenly, the ground cracked open right in front of him. Smoke hissed out, smelling of rotten eggs. Within 24 hours, that small crack in a flat field had transformed into a raging volcano 160 feet tall. Within a week, it stood 500 feet high. This was the birth of Paricutin. It wiped out 2 entire towns, leaving only the stone steeple of a church poking out of the hardened lava, a haunting monument that still stands today. This geological nightmare started in a simple cornfield, and it wasn't an isolated incident. Look at the Harat Rahat field in Saudi Arabia. In 1256, a massive fissure opened up near the city of Medina. It spewed lava for 52 days, creating a river of fire 14 miles long. Today, that same volcanic field is still there, and modern Medina has expanded right on top of the ancient lava flows. Now, apply that same story to a suburb of Los Angeles, a district in Tokyo, or a neighborhood in Europe. In a matter of days, an entire city can be buried under ash. The risk is global, ranging from over 1,800 vents in the American Southwest to the restless Eifel region in Germany and similar fields in China. Experts warn that the real risk here isn't size, but frequency and location. These volcanoes tend to be explosive. When magma rises rapidly and hits groundwater, which is common under cities and fertile farmland, it flashes into steam. This creates a phreatomagnetic explosion. Instead of a slow, oozing river of lava that people can walk away from, the ground acts like a shotgun blast. It sends a massive column of ash and rock shooting into the atmosphere. In our modern world, this is a recipe for chaos. We rely on delicate systems, air travel, GPS signals, just-in-time supply chains. You don't need a supervolcano to crash the global economy. A small eruption near a major logistics hub is enough. Remember the 2010 eruption in Iceland? That wasn't even a big explosion by historical standards. Yet, the ash cloud grounded over 100,000 flights, and 10 million passengers were stranded. Volcanic ash melts inside jet engines, while toxic dust poisons crops and contaminates water reservoirs with heavy metals. It creates a domino effect. One small eruption in the wrong place triggers a cascading failure of global infrastructure. And the most alarming part is that the signals are already there. Recent geological studies have shown an uptick in activity in these distributed fields. It isn't always violent earthquakes. Often, it's bradyseism, the slow rhythmic breathing of the ground. We mentioned the Eifel region of Germany, where GPS data shows the land is rising by about 0.04 inches per year. It sounds tiny, but for geologists, that is a proper red flag. Scientists are detecting slight swells in the Earth's crust and weird spikes in carbon dioxide emissions in places that should be quiet. Magma is moving, but because these systems are so spread out, monitoring them is a nightmare. We have sensors all over Yellowstone. We watch Vesuvius 24/7, but almost no one is watching a random patch of desert in Arizona or a forest floor in Germany. These invisible volcanoes are poorly studied. We lack the baseline data to know if a tremor is just a truck driving by or the start of a Pericotine-style event. This lack of data means that when an eruption starts, authorities might have almost zero warning. In a polygenetic volcano, the mountain swells for months. In a monogenetic field, magma can shoot from the deep mantle to the surface in hours. By the time the evacuation order is written, the lava could already be breaking through the pavement. It isn't that hard to imagine the logistical nightmare. A city not known for volcanoes suddenly receives an alert. A vent is forming downtown. It sounds impossible. People delay leaving. They grab their phones to film the smoke. Then, explosions start. The ash creates a blackout. Power grids fail as wet ash shorts out transformers. Roads gridlock instantly. This scenario isn't science fiction. It's exactly what hazard models predict for places like the Auckland Volcanic Field or parts of the Trans-Mexican Volcanic Belt. We are building denser and denser cities on top of geological landmines. This doesn't mean we need to start digging bunkers, but it does require a shift in perspective. We have spent so much time worrying about the celebrity volcanoes that we forgot about the quiet ones. The Earth is a living, shifting engine that doesn't care about property lines or city limits. Scientists are now pushing for better monitoring networks, using satellites to track even the tiniest ground deformation in these boring, flat fields. Because the only way to survive a surprise attack is to see it coming before the ground cracks open. Peace and quiet on the surface doesn't always mean peace and quiet underneath. The Earth has plenty of secrets left, and some of them are just waiting for the right moment to surface.
The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation.
And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level. And a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence. And when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
According to the United Nations, India became the most populous country in the world in 2023. Can you guess where the United States of America stands in that rating? It's number 3. And America is the 4th largest country in terms of size. It takes up some 6% of Earth's landmass. Plenty of space for 335 million people who live there, right? No need to squeeze them into one region. Well, not quite. The population of the U.S. is distributed pretty unevenly. Let's draw a line right through the middle of the country. It'll run from North Dakota in the north to Texas in the south. Once you input census data and do some math, astounding figures appear. 80% of the U.S. population lives east of the imaginary line. The remaining 20% live to the west. That's just 1 in 5 Americans. We're talking about large metropolitan areas, such as Los Angeles, San Diego, and San Francisco. You don't believe me? Just look at a satellite map of the US at night. The right part is shining pretty bright, right? But why? Why is there such a huge imbalance in population? Simply put, history and geography. The East Coast is the place where the U.S. became independent in 1776. These are the original 13 colonies. Soon enough, settlers started spreading westward. One important milestone was the Louisiana Purchase. Today, this region is mostly what we call the Midwest. The area aligns nicely with the Mississippi watershed. Yup, this means plenty of fertile soil ideal for agriculture. But does this automatically mean a spike in population? The demographics of the U.S. reveal that a majority of its citizens live either on the east or the west coast. This leaves a large patch of land in the middle of the country virtually empty. People know it as America's underpopulated belt. The area stretches from the Canadian border in the north to Mexico in the south. The total surface area of this strip of land is 350,000 square miles. That's twice the size of California. One massive piece of land. In fact, this narrow strip accounts for 12% of the contiguous United States. That's the U.S. without Alaska and Hawaii. The belt runs north to south through 7 states, but its population makes up only 1% of the total number of people living in the United States. Now, this doesn't mean that the area is completely empty. It's still home to just over 3 million people. That's roughly the population of the island country of Jamaica. But there is room here for many more residents. Let's take the example of Nigeria. Its total land area is slightly bigger than the sparsely inhabited belt in America. But Nigeria's population is a huge 206 million people. This makes it the 7th most populated country on the planet. Impressive, right? But why isn't the American Midwest living up to its potential? Well, time for one last history lesson. I've already mentioned how the United States expanded from the East Coast to the West Coast. This doesn't mean that the West was lagging too far behind. Take, for example, the cities of San Francisco and Los Angeles. They were incorporated in 1850. That's just 13 years after Chicago. The following year, Portland, Oregon became incorporated. You get the picture. And then, in 1869, the United States completed building its first transcontinental railroad. In terms of transport, the country was unified. There is no historical reason strong enough to explain why so few people live in the center of the country. So now it's time for some interesting geography. If you look at the physical map of the United States, you'll notice that this belt lies in the Great Plains. As the name suggests, the area is flat, which should be ideal for large settlements. Well, not really. East of this region, there is a huge patch of the color brown. It's covered by mountains. But not just any mountains. These are the Rockies. The range is around 76 million years old. It has several peaks over 14,000 feet. And most of the Rockies are national parks, a vast nature reserve. But most importantly, the range plays a vital role in the region's climate. Ever heard of the rain shadow effect? Let me explain. Wet weather systems form over the Pacific Ocean. Then they travel east, where they meet the Rockies. Now the air has to go up over the mountains. This is where it cools down and condenses. The final result? A lot of rain and snow for the people living on or west of the range. And just a few drops east of it. When air from the Pacific finally reaches the Great Plains, it doesn't contain much moisture anymore. In fact, the weather system starts taking up moisture from the surrounding landscape. This creates an arid climate east of the Rocky Mountains. That's the exact location of the belt where so few Americans live. It's one of the driest parts of the country. So when settlers came in the 19th century, they were like, nah, I'll just continue west. Plus, there was the gold rush in California they were heading for. The climate in this part of the plains isn't great for agriculture, and huge fluctuations in air temperature don't help either. In a single day, temperatures can drop from 70 to 30 degrees Fahrenheit. These sudden changes in outside temperature are harmful to human health. It's like stepping inside an air-conditioned room on a sizzling summer day. Not a pleasant feeling. Southern California has a similarly dry climate, yet close to 40 million people live there. This makes California the most populous U.S. state. Their secret? A vast network of irrigation canals and aqueducts, plus a share of water from the Colorado River. Summers in the Great Plains get very hot, while winters are extremely cold. The reason behind these wild weather patterns are polar winds. They get a piggyback ride along the ridges of the Rockies and then rapidly descend into the plains. A winter day in Wyoming, for example, can start pleasantly warm, but later in the afternoon, the temperature can easily drop below zero. You just wouldn't know how to dress, and you probably wouldn't want to relocate here. That's what 99% of Americans think too. Humans like to feel comfortable, so we choose to live in temperate climate zones. Places that are either too cold or too hot don't have a large population. Just look at the driest inhabited continent. You've guessed it correctly, it's Australia. Nearly 70% of the country is either arid or semi-arid. That's a subtle way of saying that it's a desert. That's why Australians are huddled in coastal areas. 90% of them live in big cities, such as Sydney, Melbourne, and Perth. The only exception is the capital, Canberra. They build it inland close to a water source. But Australia's interior is sparsely populated. Just like in the States, there is only one major town in an area the size of 12 Lake Michigans. A huge shout out to the residents of Alice Springs. They truly live in an oasis. And what about places with a temperate climate like Europe? The population is evenly distributed here, right? Well, yes and no, depending on the country. In Germany, 77% of people live in urban areas. They have plenty of major cities to choose from. Berlin, Hamburg, Munich, and Köln all have over 1 million residents. But let's look at neighboring France. How many cities with a population over 1 million can you name? Okay, Paris, definitely. It has over 12 million residents in the metropolitan area. But now comes the staggering fact. The next two cities on the list have a population of barely 2 million, respectively. Can you notice the huge imbalance? This is the case in most large European countries. In Greece, for example, 35% of the population lives in the capital, Athens. So, the largely underpopulated center of the United States is not a unique example. America is the land of opportunities, but chances of finding a better life are greater in large cities. The country's top 100 metropolitan areas account for at least 3/4 of the nation's GDP, and most of them are located on the east and the west coast. There are no cities with over 1 million residents in America's underpopulated belt.
There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive.
Let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Uturuncu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years, by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Uturuncu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Uturuncu probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campi Flegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is, there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it.
around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. But more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington state in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. But experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. It will change the way the volcano might erupt. Popocatepetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatepetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too surprising, and they're keeping a close eye on it. See how the Antarctic Peninsula looks just like South America, but upside down? This isn't just a coincidence. It's the ghost of a 30-million-year-old breakup. These continents were once connected, but their divorce gave birth to an ocean current so powerful it was capable of completely freezing Antarctica and shaping its landscape. Here's how it went down. Tectonic plates pulled a sneaky move and cracked open a ridiculously narrow passage in the ocean, about only 500 miles wide, forcing 4.5 trillion cubic feet of water to flow inside this geological straw. This was the birth of an ocean current stronger than the Amazon River. This ocean current, called the Antarctic Circumpolar Current, by the way, flows in a circular motion, going clockwise because of the strong winds that blow over there. This circular motion around Antarctica caused erosion, shaping the landmass of the continent into a circle, except for that stubborn peninsula, which is being slowly dragged east like a kid refusing to leave a playground. Wait, South America and Antarctica used to be one? Yep, a long time ago. South America, Australia, and Antarctica were all part of a supercontinent called Gondwana, which also included Africa at some point. Back then, South America and Antarctica used to be basically joined at the hip by a land bridge called the Antarctic Land Bridge,
which just so happened to be a lush green forest and also a great dinosaur highway. Yeah, you heard it right. Dinosaurs. A 95-million-year-old dino, whose name I can't pronounce, sorry, was discovered in Australia, and scientists found out it had actually been a distant cousin of Argentina's Sarmientosaurus. Same jaw, same chiseled teeth, same everything. These guys were like identical twins, separated by an ocean. How? Because back then, Antarctica wasn't a frozen wasteland. It was a temperate rainforest, like Oregon, making it a pretty nice travel route for a dino family. But the land bridge wasn't just for dinosaurs. About 40 million years ago, the ancestors of Australia's marsupials waddled to the land down under all the way from South America, taking the Antarctica route, another proof that these continents used to be connected. Things remained somewhat peaceful for the dinos and the marsupials until Earth's ground started moving. This is what a German scientist called the continental drift theory, back in 1912. Our German friend here basically looked at the coast of South America and went, "Hey, this looks like it could fit into the coast of Africa." Like a scientific Sherlock Holmes, he noticed what others had overlooked for centuries. The continents were clearly pieces of a larger puzzle. And he was right. Here's the deal. Planet Earth is made of many layers of rocks and metals, like a cosmic onion. The outermost layer, the lithosphere, is divided into pretty solid tectonic plates that move atop a layer of softer, somewhat molten rocks, like slippery ice. This is why the plates move. In fact, they've been rearranging Earth's face for billions of years, with supercontinents forming and breaking apart in cycles, like a slow-motion game of bumper cars. This movement might be pretty slow since most tectonic plates only move 0 to 3.9 inches every year, except for the Nazca plate, racing ahead at 7.8 inches, about as fast as your hair grows. But don't let their snail's pace fool you. These shifting slabs are the ultimate planet shapers. Their slow dance gives us everything from earthquakes that build mountains, like the Himalayas, to rifts that birth oceans, like the Atlantic. All because the oceanic crust is dense and sinks like a stone, while continental crust floats like a cork. It's this density difference that explains why continents exist at all. Without it, Earth would be completely covered by shallow seas. This slow-motion planetary renovation project is exactly what tore South America and Antarctica apart 30 million years ago. The plates under these continents started to drift apart in a process called crustal extension. It's like the lithosphere was pizza dough being slowly stretched until it thins and splits. As the crust stretched, it became thinner and weaker, eventually cracking like the surface of a drying lake bed. This whole thing gave birth to a new tectonic plate, the Scotia Plate, that emerged between South America and Antarctica, like a geological divorce lawyer. For a while, parts of this plate stayed above water as the last gasp of the Antarctic land bridge. It was Earth's version of that one thread still connecting your hoodie after the zipper breaks. These final connections might have persisted as chains of islands, but just like that fraying hoodie, the connection couldn't last forever. Eventually, this small but mighty plate became the final nail in the coffin of the land bridge connecting the two continents. Just like all the tectonic plates, this one was also on the move. As it expanded eastward, it opened a new passage of water called the Drake Passage, slowly covering the Antarctic land bridge with ocean water. The process was like pulling open elevator doors. At first, just a crack, then wider and wider until the connection was completely broken. This geographical divorce had chilling consequences. The new Drake Passage allowed the Antarctic circumpolar current to form, creating an endless loop of cold water that isolated Antarctica, shaped its land, and even cooled the entire planet. This current acts like a wall around Antarctica, blocking warm water and invasive species while regulating global climate. Eventually, Antarctica turned into an icebox that is 98% covered in ice sheets, and that holds about 61% of Earth's fresh water. Nowadays, this continent holds the title of the windiest, driest, and iciest place on Earth. It's a frozen desert where temperatures plunge below -128.6 degrees Fahrenheit. cold enough to freeze your breath mid-air. A layer of ice there can be more than a mile thick, and it expands even further in winter to cover an area larger than the continental United States. Today, if you want to travel to Antarctica, the quickest sea route is through the Drake Passage, a 500-mile-wide body of water that is narrow enough for the winds to scream across thousands of miles, transforming into monstrous waves that can tower up to 49 feet. Though calm days create waves only 13 to 16 feet high. Still twice as tall as Atlantic waves, mind you. This is probably why sailors call this stretch of ocean the Drake Shake. But tectonic movement isn't just about shifting continents. It's Earth's ultimate life support system. You see, about half of our planet's heat comes from radioactive decay in the core. Thanks, uranium-235. Something like nature's nuclear reactor. This heat is behind everything from volcanoes to the very plate motion that once connected Antarctica to South America. And it only comes out of the core because of tectonic movement. Without this internal heat engine, Earth would be just like Mars. When the plates move and release heat, they also release CO2 gases into the atmosphere, regulating the temperature of our planet. And when the plates move underwater, they take a lot of this CO2 back to Earth's interior, recycling all this gas. This is why the plates can change our air, climate, and even the evolution of life itself just by moving around. But billions of years ago, these plates were not moving around. Back then, it was like Earth was wearing a solid ceramic shell with many cracks. But even without tectonic movement, the heat managed to escape through these cracks in a process called stagnant lid tectonics, kickstarting all life on Earth. And no, tectonic movement is not a thing of the past. Earthquakes are the living proof that it is not just happening today, but might repeat again on a more dramatic scale in the future. You see, to form supercontinents like Pangaea, smaller megacontinents have to dive beneath another. And scientists predict that a similar process might create a new supercontinent called Pangaea Proxima in 250 million years. By then, humans might be extinct or living on Mars, but Earth's tectonic dance will continue, even without us. Not bad for something that moves more slowly than a traffic jam. Turns out, Antarctica and South America used to be BFFs before all that tectonic drama split them up, like a messy breakup that literally froze one of them out. Now, they just awkwardly mirror each other from across the Drake Passage. Classic exes.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American Plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing because it sits on the African plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, you know? But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking. And the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a cabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
These dark patches on Greenland's ice sheet aren't just any old stains. Every summer, the ice, which is usually bright white, turns murky gray in certain areas. This so-called dark zone was a huge mystery for a long time, until some studies discovered that this weird transformation was connected to the odd appearance of red, green, and brown-colored algae. The scariest part is that this algae bloom keeps growing. The dark zone is getting darker, and terrifying microbes might start appearing. Now, the rest of the world should be concerned. The Greenland ice sheet is like a massive ice blanket that covers around 80% of the island. It's so thick that it holds about 8% of the world's freshwater ice. For most of the year, the ice looks like a giant untouched white sheet stretching over the land. But when summer rolls around and temperatures start to rise, things begin to change. The ice melts, revealing rocky areas along the coast. And as you move further inland, that once smooth white ice becomes darker. This is the dark zone, and it covers an area of around 248 miles in length and 62 miles at its widest point. This weird phenomenon happens basically for two reasons. The first one is black carbon. Just like dust that builds up on your bookshelf, the ice in Greenland has the same issue. The wind carries a mix of dust and soot to this icy area. But unlike your bookshelf, you can't just wipe it off with a cloth. In Greenland's case, this dirty mix settles on the ice and sticks around for thousands of years. So, the dark zone is basically covered in a fine layer of dust that's built up over time. Back in 2014, researchers analyzed this dirty mix and found that the darker ice areas were filled with black carbon. This black carbon didn't just appear out of thin air. Well, actually, it sorta did. Scientists believe it mostly comes from smoke produced by wildfires in northern Canada and Alaska somewhere in the past. As you might guess, black carbon is black, which is why it makes the ice look darker. Now, the second big reason for the Greenland ice sheet's summer makeover has to do with those algae we mentioned earlier. We're mostly talking about two types of it, the Ancylonema alaskana and the Ancylonema nordenskjoldii. Both of them love cold water regions. During winter, they stay in a dormant state deep within the ice. But when spring comes, they start to slowly migrate to the surface. By the time summer hits, they're ready to bloom and soak up nearly 24 hours of sunlight each day for photosynthesis and growth. Normally, these algae are green, but when exposed to sunlight, they turn brown as a natural way to protect themselves from harmful ultraviolet rays. And this color change is also what makes the ice in Greenland look darker. So far, this has been normal behavior. What's really alarming is that these algae blooms are getting bigger and bigger every year. This happens because they thrive on phosphorus, a nutrient that's plentiful out there and comes from a mineral called hydroxylapatite. This mineral is found in a type of rock that breaks down into tiny dust particles, which are then blown across the ice by the wind. As the climate gets warmer, the rocks dry out more, and stronger winds carry more dust. More dust means more phosphorus, leading to more algae growth. See? It is a cycle, and it keeps getting worse every year. Studying this is crucial to understanding why the dark zone keeps getting bigger. From the year 2000 to 2012, its size increased by 12%. But you might be wondering, why should we care? After all, it's just ice getting darker, right? Well, not exactly. Think about how you can't stand wearing black clothes on a hot, sunny day. They soak up the heat and make you feel even hotter. That's because darker surfaces absorb more sunlight. The same thing happens to ice. Together, dust, black carbon, and algae blooms are responsible for about 70% of the variability in albedo on the Greenland ice sheet. Albedo is just a fancy word for how reflective a surface is. If you take two surfaces, one white and shiny and the other dark and rough, the white one will reflect a lot of light and heat, giving it a high albedo. The dark one, on the other hand, will absorb more light and heat, so it has a low albedo. During the summer, the Greenland ice sheet experiences a reduction in albedo. This means the ice absorbs more sunlight, and when ice absorbs more sunlight, it melts faster than it should. This is why understanding what's happening in the dark zone is so important. It helps predict how quickly the Greenland ice sheet is melting and how it can affect the rest of the world. Greenland's ice sheet is the second largest in the world, covering an area about the size of all the land in the United States east of the Mississippi River. And its huge mass of ice averages a thickness of 1.4 miles. Unfortunately, the ice loss has skyrocketed. Back in the 1990s, Greenland was losing about 25 billion tons of ice per year. Now, it's losing around 234 billion tons per year. That's nearly 10 times more ice melting away each year. According to NASA, if all of Greenland's ice sheet were to melt, it would increase global sea levels by about 24 feet. That could be catastrophic for coastal countries and cities around the world. The Netherlands could be submerged, the Bahamas could be almost completely wiped out, and many of the Philippines Islands would be at risk of disappearing. All of this may seem like a distant reality, and it is true that most scientists believe it would take several hundred or even thousands of years for the ice sheet to melt completely. But it is important to know that Greenland didn't always have this thick layer of ice. Very recently, researchers took a close look at some sediment from the bottom of a 2-mile deep ice core extracted from the center of Greenland. They found that the soil had traces of willow wood, insect parts, fungi, and even poppy seeds. So these fossils are the first direct evidence that Greenland's ice sheet melted away in the recent geological past, around 400,000 years ago. At that time, Greenland was home to a green tundra landscape with insects and plants. This discovery is both fascinating and scary because it shows that the ice sheet collapsed before and might be more fragile than scientists originally thought. There is another concern too. A recent research collected meltwater from different spots on the Greenland ice sheet and found that the water samples were packed with hundreds and thousands of microbes. The concern is that they could be released into the ocean in the future. And some studies already suggest that areas near where a lot of glacial meltwater flows have a higher risk of viruses jumping to new hosts, like from animals to humans. Even though experts believe the chance of a doomsday virus coming from the glaciers is very small, it's still not zero. The truth is, we don't know much about the thousands of microbial species living on the surface of the ice, and there is simply not enough data to fully understand how dangerous these organisms might be. All of this might sound concerning, but we shouldn't panic just yet. There's still a lot we don't understand about what is darkening the Greenland ice sheet. We still need more detailed measurements of the relative abundance of dust, algae, and black carbon, as well as a better understanding of how these potentially dangerous microbes could affect our lives. The more we learn, the better we can predict what's going to happen and how we can prepare for it. This area might just be the most important spot in America right now, as it is worth over $1 trillion. There's something incredibly valuable hidden right here at Thacker Pass, and it is going to shake things up, not just in Nevada, but in the US economy and its global relations. The McDermott Caldera is a massive area, about 28 miles long by 22 miles wide, stretching across northern Nevada and southern Oregon. It's in Humboldt County, a quiet, rural place with just one main city that's going to change a lot in the next 5 to 10 years. That's because they found white gold there. We're talking about lithium. And to explain why this metal is so important, we need a scale. On one side, we place a chunk of lithium, and on the other, an apple. What do you think will happen? If both have the same volume, the scale is going to tip toward the apple. That's because lithium is super light. Its density is about 0.3 ounces per cubic inch, which makes it the lightest solid you can find at room temperature. Lithium is also extremely reactive. That means it combines with other elements very easily, and it can catch fire just as easily. Mix it with water, fire. Expose it to air, yep, fire again. But when you combine its lightness with its high reactivity, you get a material that's perfect for batteries, like the one powering your smartphone, laptop, or even your electric car. Nevada's been hiding this treasure for about 16 million years. The McDermott Caldera used to be a volcanic hotspot, spewing molten rock and creating a huge lake filled with mineral-rich waters. Over time, that lake dried up, leaving behind thick layers of clay loaded with lithium. Right now, Thacker Pass Mine is sitting on one of the biggest untapped lithium reserves in the world, worth about $1.5 trillion. If everything goes as planned, they expect it to produce about 40,000 tons of high-quality lithium a year. And that's enough to make batteries for up to 800,000 electric cars. Like I mentioned earlier, this metal is the backbone of modern batteries. And with the world racing toward green energy, the demand for lithium is skyrocketing. Since 2020, its price has gone up more than 10 times, making it the most expensive battery metal in the world. That means it's way more expensive than magnesium, nickel, cobalt, and other materials used in rechargeable batteries. Right now, we're using about 1.16 million tons of lithium per year, and roughly 85% of it goes into making batteries, mostly for cars. Between 2030 and 2040, experts think we will need to double the money we're putting into production, from $94 billion to $188 billion. At the same time, investment in batteries will jump by over 200%, reaching $686 billion. Finally, by 2050, the demand for lithium is expected to be more than 10 times higher than what we're producing now. Sorry, I know that's a lot of numbers, but I just want to show how important Thacker Pass will be for the whole world. This mine is going to be key to keeping everything running. I mean, literally, since most of the future demand will be for things like cars, electric bikes, scooters, and renewable energy storage. Nevada could also be the epicenter of a global energy revolution, with the US aiming to cut pollution by 50% by 2030. A big part of that is replacing gas-powered vehicles with electric ones. And to make that happen, America is going to need a whole lot more lithium than it's producing right now. Nowadays, most of the metal used in the United States come from countries like Chile and Argentina. So if America wants to be a leader in this market, it really needs to invest more and more in projects like Thacker Pass. But there's another challenge. Finding lithium in a mine is one thing, but refining it is another story. Just like diamonds are carefully cut and shaped to bring out their sparkle and sold in rings and necklaces, something similar needs to be done with lithium. The raw material that comes from the mines has to be refined into a pure form that can actually be used in things like batteries. And China pretty much dominates this part of the market, and they're responsible for about 75% of global lithium-ion battery production. In other words, it doesn't matter if a country finds this powerful metal on its land, it will probably still need China to help refine it. So, the US is eager to strengthen its supply chain. In fact, they're so excited about this possibility that authorities have invested over $2 billion in loans into the Nevada project. Because of that, Thacker Pass could make the US a leader in lithium production worldwide. If their estimates are right, the McDermott Caldera could hold nearly half of the world's known lithium reserves. It would almost double the reserves found in Bolivia's salt flats, for example, which used to hold the record for the world's largest deposit. This discovery is about to change Humboldt County for good. Those quiet streets surrounded by nature will never feel the same again. The mine will need about 2,000 workers who will probably move there from other cities. Those workers will need houses, hospitals, schools for their kids, and all the necessary services. Do you see how it's like a ripple effect? For every person hired to work on the project during construction, 6 more people will get hired in the state to support them. Thacker Pass is also going to have a huge impact on the economy, not just in Nevada, but all across the country. People expect the mine to be active for 35 years, and each year it's expected to generate over $2 billion. But here's the thing. In Thacker Pass, they'll be extracting lithium from clay, and this process has never been done on such a huge scale before. So it's kind of a hit or miss. But if it works, it could completely change the industry. Big question. Who's interested in all this? Well, we've got 3 big companies eyeing the lithium market in the US. First, there's ExxonMobil. The oil giant wants to start producing lithium by 2027, and they have plans to become the top supplier for electric vehicles by 2030. Then there's General Motors, the company behind big car brands like Chevrolet and Cadillac. They're so interested in this business that they agreed to pay $625 million for a 38% stake in Thacker Pass. And finally, Tesla. In 2023, they started building a factory in Texas to process lithium. It's all part of their plan to handle more of their supply chain themselves. Now that you know how important lithium is, you might be wondering, what if we run out? Well, that could happen, since it comes from mining and, just like gold, is a finite resource. But that doesn't mean we'd have to give up smartphones or electric cars. If we ever run out of this metal, we'd probably find new ways to produce batteries. In fact, some experts think thermal batteries could be the next big thing. They store extra energy from renewable resources like wind or solar power, which are very cheap. So they represent a new way of storing energy at a small fraction of the cost. Nowadays, they're primarily used for powering the production of steel, cement, and chemicals. Thermal batteries are also being used to heat and cool large buildings. However, more and more projects are focusing on bringing this technology into private spaces, like houses and apartments. Experts are optimistic that initiatives like these could make thermal batteries as well known as electric batteries, and they might soon become a regular part of our daily lives. There's a stretch of water that even the most experienced explorers fear. No matter what season you choose to cross it in, you risk meeting face-to-face with waves that can reach as tall as the Hollywood sign. I'm talking about the Drake Passage, the waterway connecting the Pacific Ocean to the Atlantic Ocean, stretching from Cape Horn at South America's southernmost tip to Antarctica's South Shetland Islands. It's about as wide as the distance from London to Berlin and takes up to 48 hours to cross. Some sailors compare getting on the other side to going to the moon. That's how challenging it is. Even the man who discovered it, Sir Francis Drake, never sailed these waters because they seemed too dangerous to him and opted for a calmer, although longer, Strait of Magellan. The passage took the lives of around 20,000 sailors and over 800 ships. Tourists who want to see Antarctica cross the Drake Passage on a regular basis, although it's still often called the world's most terrifying ocean crossing. The Antarctic Peninsula, where travelers go, isn't really part of Antarctica itself. It sticks out and points towards South America like two fingers almost touching it. The water gets squeezed between these two land masses, making strong ocean currents. The passage is part of the Antarctic Circumpolar Current, the largest ocean current on Earth. The water rushes through the passage at a speed between 95 and 150 million cubic meters per second, which makes it rougher. And then there are winds that usually blow from west to east and are very strong between 40 and 60 degrees latitude. That's why those areas are called the Roaring Forties, Furious 50s, and Screaming 60s. Land slows down winds, which is why storms hitting Ireland and the UK get weaker as they move east. But Drake's latitude is the only place where winds can blow all around the Earth without being stopped by land. So they keep getting faster. These strong winds turn into huge waves that can hit ships really hard, normally around 13 to 16 feet tall. They're much higher than waves in the Atlantic. Drake Passage also has underwater mountains that you can't see. The huge current squeezes through this narrow passage and causes waves to crash against these mountains underwater. These internal waves create whirls that bring cold water up from the deep ocean. So it's not just rough on the surface, the water is wild all the way down. The first sailor managed to sail around Cape Horn and through the Drake Passage in 1616. It was a Dutch navigator, Willem Schouten, in 1616. But the most famous attempt to cross it was undertaken by Sir Ernest Henry Shackleton on his ship named Endurance. He and 27 of his men set off from South Georgia, aiming to reach Vassal Bay in Antarctica. But things didn't go as planned. On January 19, 1915, their ship got stuck in the ice. And by October, it began to sink. They camped on floating ice for 2 months before sailing lifeboats to a remote, icy place called Elephant Island. Shackleton and 5 men made a risky journey to South Georgia to get help. It took them 15 days to cross Drake Passage with hurricane winds. Finally, they arrived safely and organized a rescue for the rest of their crew. Scientists found the shipwreck of Endurance only in 2022, 10,000 feet below the water. In December of 2019, 6 fearless athletes decided to cross the Drake Passage by rowing a boat for the first time in history. It took them 12 days of non-stop rowing with a 90-minute rotation of rowers. They managed to do it, and it was probably the hardest possible way to cross the passage. The athletes mentioned it was cold, wet, and dirty, and the waves hit them like walls. The weather in the Drake Passage changes a lot, but ship captains can always see it coming and change their path. They will move the departure time to have a safety margin and not to get stuck in the middle of the passage in the worst possible conditions. Sometimes, the journey will be smooth and calm, and they call it Drake Lake. Other times, people on the ship will feel rough waves, which is called Drake Shake. Some experienced captains who often cross the passage say that the Drake Lake effect happens once in every 10 crossings, and they see the Drake Shake once or twice in every 10 journeys. A schooner or a kayak will probably not survive the journey among giant waves, but modest vessels and cruise ships have sturdy hulls and advanced stabilizing mechanisms. So, the journey isn't that dangerous anymore, but still, it's quite an adventure, especially if you're seasick. If you don't feel like risking it but want to travel from the Pacific Ocean to the Atlantic Ocean by water the fast way, the Panama Canal is waiting for you. People first started thinking about making a water path across Panama in the 16th century. Back then, a Spanish explorer found out that only a thin piece of land separated the two oceans. But it seemed impossible to build it because of the mountains and thick jungle, so the idea had to wait a couple of centuries. Finally, in 1880, France, led by the man who built the Suez Canal in Egypt, tried to make the canal. But the people who started the construction soon found out it was much harder than it looked on a map. The land in Panama was one of the toughest and most dangerous places to dig a big waterway. workers had to literally move huge mountains in a jungle full of snakes, where it was really hot and rainy. During the wet season, heavy rain turned rivers into wild rapids and soaked the workers. Sometimes, they didn't see the sun for 2 weeks, and their clothes stayed wet all the time. Big rocks were falling, and tiny mosquitoes that carried malaria made people very sick. And then, an earthquake happened on top of everything. They were losing thousands of people. That's why France decided to abandon the project after 7 years. Then, the United States bought the French assets in the Canal Zone and finished it by 1914. It cost the US around $375 million. The 50-mile-long passage of water saves ships traveling between New York and San Francisco 7,872 miles. Around 14,000 ships use it every year and pay around $1.8 million in tolls. So it looks like it all paid off. Another challenging waterway in this part of the world is the Amazon River. It's around 4,300 miles long and flows through 3 countries with over 30 million people living in its basin. But there isn't a single bridge across it. The river has many marshes and soft soils, so engineers would need to build very long bridges and very deep foundations, which costs a lot of money. Building bridges over deep water is tough, but in other places in the world, engineers can use things like floating platforms to help. The river's path and water levels change a lot during the year. During the dry season from June to November, the river is usually 2 to 6 miles wide. But in the wet season from December to April, the river can become as wide as 30 miles. And the water level can rise by 50 feet. That's why they can't build floating bridges or pontoons. The riverbanks are made of soft dirt that moves and erodes with the seasons, and it makes things even harder. It would have to be an absolutely unique project to overcome all these challenges. Luckily, there's no pressing need for a bridge across the Amazon right now. The river mostly goes through areas that are sparsely populated, so there aren't so many major roads to be connected by bridges.
Do you know that our planet has scars? One of them is located in North America. This scar can tell us many cool things about the history of Earth, but the most interesting thing is that it could change the appearance of our continents and break our world. But for some reason, this scar hasn't done it yet. And that's not even the most interesting part. The coolest thing about this scar is that it might hold a giant source of clean, cheap energy. So let's go to Kansas to find out what it is. So, 1.1 billion years ago, a giant rift formed in the crust of our planet on the territory of the modern U.S. Midwest. It's called Broken Heart. This giant crevice is filled with solidified magma, and from afar, it looks like a real scar. But how did it show up? Broken Heart was an ancient rift valley, a huge geological fault forming elongated hollows in the Earth's crust. It occurred because tectonic plates had moved apart. It's like the details of a jigsaw puzzle that suddenly started to separate. At that moment, thousands and even millions of tons of magma spilled out from the depths of our planet. That event looked like a real apocalypse, lasting about 100,000 years. But then it stopped, and scientists don't know why. If the rifting process had lasted longer, then most likely the continent of North America would look different today, or it wouldn't even exist at all. Right now, this fault looks like a giant horseshoe that stretches from Kansas north to Lake Superior and south to Michigan. But some studies indicate that the fault may be larger and extend even further south, and the width of the fault might equal the width of the Red Sea. After the rifting stopped, the entire valley got covered with hills and trees. The fault itself is covered with a thick layer of sedimentary rocks, so it's quite difficult to track. The most noticeable parts of the rift are in the Lake Superior area. Now everything looks calm and beautiful, but in the past, there were fountains and rivers of lava, earthquakes, a boiling pot on a planetary scale. All that remains of it are deposits of basalt, a dark, dense rock that forms from cooled lava. There was so much basalt that its weight pushed the valley deeper and deeper into the Earth's crust. Even when the eruptions and rifting stopped, the valley continued to sink because of the huge mass of this sediment. Then, massive sections of the Earth's crust on both sides of the valley began to contract, and the pieces of the puzzle slowly started to come together. This led to a large-scale ejection of volcanic material upward, and along with basalt, deposits of copper rock appeared in the valley. People mined this copper for about 8,000 years until the end of the 20th century. The copper mines were eventually shut down, but now it seems the industry is making a comeback. However, Broken Heart is not interesting to people just because of its copper reserves. It holds something more valuable and useful for our civilization. Scientists believe that this valley hides massive reserves of hydrogen, and this substance can help us switch to a cleaner, cheaper, and more efficient energy source. If hydrogen fuel becomes widely available, everyone will switch to it, leaving behind the costly, noisy, and polluting process of oil production. Now, I'll bet hydrogen is a remarkably familiar word to you. It doesn't sound like the discovery of the century, and people have been using it for a long time. On one hand, you're right, but not quite. 90% of the hydrogen produced by humans is used as a raw material for the chemical industry. Hydrogen is used to produce ammonia for fertilizers, methanol for fuel and solvents, and to purify crude oil. Manufacturers of glass, cement, steel, and other metals are considering using hydrogen at their factories for more efficient production. Hydrogen can become an alternative to fossil fuels, that is, oil and gasoline produced from them. Cars, ships, trains, airplanes, and power plants, all of these may switch to hydrogen soon. In this case, production can become cheaper and better for nature. But this will work only if we find open sources of hydrogen. You see, about 95% of the hydrogen we use is produced from fossil fuels. We gasify coal, oxidize hydrocarbons, and extract hydrogen from methane. All of these production methods require energy. But the worst part is that they lead to large emissions of carbon dioxide into the atmosphere. But what if we find sources of pure hydrogen that don't require processing? Then we'll save energy for its production and make the planet cleaner. But where can we find such sources? Scientists say that there are many of them all over the planet, and one of the largest is located in the Rift Valley in the U.S. Midwest. But what's the problem with going and mining it? Well, it's not that simple. To extract pure hydrogen, you need 3 conditions. The first is the source of hydrogen itself, which is quite logical. The second is reservoir rocks, that is, natural containers where this hydrogen is stored. And the third is natural seals, which prevent the gas from escaping. In other words, these seals work like a cap on a bottle. They don't allow the substance to escape. So in general, it's necessary to find where hydrogen is released, where it accumulates, and where it's stored. When these conditions are met, natural resource extraction companies can start working. But how does hydrogen appear altogether? Well, let's go over the basics of chemistry. Hydrogen and oxygen compounds form water. This means you need to split the water into hydrogen and oxygen. This process often occurs in nature. There are many places all over the planet where this happens. Scientists are confident that at least 30 U.S. states have hydrogen reservoirs. And if people detect them, we will accelerate the energy transition to safer and more efficient fuels. Thousands of cars drive around using gasoline. Many of you know the smell of exhaust fumes, that thick polluted air that's hard to breathe. What about electric cars? They must be improving the situation, right? Well, here's another problem. Producing batteries for these vehicles harms nature. The materials used to make batteries are lithium, cobalt, and nickel. Their extraction involves a large release of toxic materials, not only into the air but also into the water. Transporting these batteries also creates a large carbon footprint. Producing a single electric car emits about 4 tons of carbon dioxide. To make up for that, the owner needs to drive it for at least 8 years. That's how long it takes to offset the emissions a regular car would produce. What about reliability and convenience? What will you do if the battery runs out during the trip and there are no charging stations nearby? This problem will be solved in the future with the growing popularity of electric cars. Now, scientists believe that over the past billion years, the Earth's crust has split enough water into hydrogen and oxygen. Our planet keeps this gas in the ground, waiting for us to start using it. According to calculations, even considering all the technologies and production capacities of our civilization, the reserves of hydrogen in the bowels of the planet are enough to supply us with energy for 170,000 years. That's why the giant rift in Kansas attracts scientists from all over the world. Huge quantities of basalt and other rocks can react with water to release hydrogen. And now scientists are looking for places where this material accumulates and is stored.